My name is Nur Farahin binti Egani and my number matrix is B0819104337.
Hi, Assalamualaikum. My name is Nur Izzati Nadia binti Muhammad Nazin and my matric number is B08191045.
Assalamualaikum warahmatullahi wabarakatuh. My name Haris Hakimi bin Heri. Number matrix B0819105259.
Hi, my name is Muhammad Harish Ilman bin Rosli and my metric number is B0717100535.
And hi, my name is Siti Nurjana Karmila binti Nur Azmi and my matrix number is B0819110235. So today we're going to present about the assignment for this project. So first figure is the figure or the block diagram of this project, and the second figure is the circuit based on the block diagram above. So in this figure we have oscillator 1, oscillator 2, the active filter, rectifier, and also the voltage regulator. And as you can see here, we also have a load resistor.
Okay, my part is oscillator 1, so the requirement is resonant frequency is in 1 kilohertz, and then this is the formula that we use and assume value capacitor is 3 nanofarad. This is the formula for frequency, which is 1 over 2 pi RC, and then we rearrange to get the value of resistor, and we get 53.05 kilo ohm. And then we apply to the formula to get the frequency. The feedback resistor 2 times RA, which is we use RA as 20 kilo ohm and we get 40 kilo ohm. The 40 kilo ohm is the ideal resistance that we have to apply on circuit in multi-C. So this is the oscillator 1 that we construct, and we apply the capacitor value 3 nanofarad and the resistor that we calculate before 53.05k, and we set the RA to 20k, and this is the ideal resistance at the feedback resistor. Okay. So as we can see, this is in 40 kilo ohm. So we're gonna set the output to see the frequency value. This is when 100 kilo ohm, and we have to change to the ideal value, which is 40 kilo ohm. Okay, as we can see here, clipping will occur when the wave is in ideal resistance, which is at 40 kilo ohm. And the frequency that we get is same as the calculation, which is 995 Hz, and the calculation is 1 kilohertz.
Okay, so hi, my part is oscillator 2, which the resonant frequency given for this oscillator is 20 kilohertz. So this is my calculation. To get R1 equals to 2 using formula 2 times R2. Then we choose R2 is 20 kilo ohm. Therefore, the R1 is equals to 2 times 20, then we get 40 kilo ohm. So then RC is equals C, resistor is equals to the capacitor. So the capacitor assume that 0.22 microfarad. So the formula is we use formula 1 over 2 pi RC. and 1 over 2 pi times RC equals to 20k. And to find R equals to 1 over 2 pi times C times FR. Then therefore the frequency that we get is 36 ohm. So proceed to the multisim. Okay, so this is my circuit originated. So from 100 reduce to 40 to get similar result from 20k by using the resistor value that we find in the calculation. So this is the result I get.
So next is the active filter. So this is the calculation for the active filter, which is for the low pass filter. So the cutoff frequency is equal to 8 kilohertz, and the formula for the cutoff frequency is equal to 1 over 2 pi RC. Okay, here is the R1 equal to R2 equal to R, and C1 equal to C2, which is equal to C. So here I assume C is equal to 10 nanofarad. So when the FC is equal to 8 kilohertz, and the formula is 1 over 2 pi R, which is I need to calculate, and the C is equal to 10 nanofarad, which is I assume just now. So the R is equal to 1 over 2 pi times 8 kilohertz times 10 nanofarad, which will be equal to 1.989 kilo ohm, which approximately equal to 2 kilo ohm. So in second order of Butterworth response, the R1 over R2 is equal to 0.586, which is in the R2. In this case, for R2, I assume R2 is equal to 1 kilohertz. So to calculate the R1, I need to times 0.586 with R2. So when 0.586 times 1 kilohertz, the R1 will be equal to 586 ohm. Next, we move to the simulation. So this is the circuit that I already calculate after the calculation, and this is the circuit that I designed. So I use the Vin is equal to 10 Vpeak, and the frequency is equal to 1 hertz. So this is the result for the plotter. So based on the blood plotter that displayed here, it shows the frequency response of the filter to be nearly flat for low frequency until it reaches cutoff frequency point, which is 8 kilohertz. So here is the cutoff frequency. This is because the reactance of the capacitor is high at low frequencies and blocks any current flow through the capacitor. So that's all for the low pass filter.
So Assalamualaikum, this is for my part, full bridge rectifier. So the procedure is we need to construct full bridge rectifier with a capacitor filter, calculate VDC, VP out, and V ripple, and also simulate the circuit. So first for the VDC, the formula is 2 V peaks dividing by pi, so we get 12.732 for VP out equal to VP in minus 1.4 volt, and we get 19.6 volt. And for V ripple, this is the formula, I dividing by 2FC, and we get 204.317 millivolt. So this is circuit. So this is in multisim. So I simulating the circuit. So as we can see, so for the first yellow graph is refer to the input, and the second graph is refer to the output. So based on that, so I can see that based on the figure, we use a 20 VPK and 30 Hz as input and apply to the loads. So what happened to this second wave is because of this capacitor. So as we know that capacitor is the electronic device that store and release electricity in the circuit. So when voltage is rising, the capacitor is in charge. That means store the energy, and when the circuit in the negative polarity, the capacitor will discharge it quickly and provide the energy to the supply, energy and supply to the circuit. So because of that activity, we get the smoothie, what we call output, and it will stay in the positive polarity. So thank you.
Okay, this is the last part of our project, which is voltage regulator, and I'm going to present it. Okay, the specification of this voltage regulator is the output voltage must be 5 volt, and the voltage regulator type must be OM shunt regulator circuit, and the load power is 1 watt. Okay, what we need to do is to calculate R1, RS, R2, and R3, and then to construct the circuit using the calculated value using a proper op-amp, Zenodiode, and BJT. With the given output voltage and load power, we need to calculate the resistance at the R4, and then we need to tabulate the data. Alright. How do we get the output, the load rated power? By using the formula of P equals to V squared over R. And then we get the power is 1 watt, the voltage is 5 volt, and then we will get the load resistance, which is 25 ohm. Alright. The output voltage from R4 is the same from the output voltage of R2 parallel with R3. Since it is parallel, so we use the voltage divider formula to get the output voltage of R2. So as you can see, I'm assuming the value of the R2 and R3 is 2 ohm, and then we get the voltage across R4 is 5 volt, and then we get the voltage for R2, VR2 is R2 parallel with R3 times with the VR4. So we also get 5 volt. Okay, for the Zener diode voltage, it must be compared with the feedback voltage from R2 and R3, which is it might be slightly different from the values of the voltage that we get. Okay, the value voltage of Zener diode is 5.202 volt. Okay, and meanwhile for the RS is I keep it 1 ohm to maintaining the output of the voltage from load resistance. Right now we go to the simulation. Okay, before that, this is the results. As you can see, this is the results that I get. Okay, now we go to the what we call simulation. Okay, this is the simulation, the circuit that I have done. Okay, let's run simulation. Okay, now as you can see, this is the Zener diode voltage. This is the R2 parallel with R3 voltage, and this is the load resistance voltage. And we need to make sure if it is 1 watt or not for the load power. So I'm using the wattmeter, and then this is the result. Okay, it might be slightly different from the calculation because due to the resistancy of the circuit. Alright, I will wrap up this project. Thank you for watching us and have a good day, sir.